Here we go with another of our utility videos. We're going to take a look at a problem that we've already solved once using the shopping cart method in a different video. This problem asks us to answer this question. It's going to be based on the table below, showing the marginal utility schedules for product X and product Y for a typical consumer. That's you. The price of product X is $4. The price of product Y is $2. The income for the consumer is $20. Now, if you wanted to, you could write a budget constraint here. 20 equals 4x plus 2y. But you don't have to do that here. All we want to do is find the utility maximizing combination of product X and product Y. And our output is going to be what we really are trying to find in order to make this work is the total utility of that optimal bundle. All right? So what we need to do in order to solve this problem is calculate the total utility for each bundle. One method that we already used in another video is the shopping cart method. That's where we figure out what the optimal bundle is by buying whatever gives us the best bang for our buck. A second method is to directly calculate the utility of all of our feasible bundles and pick the best one. That's what we're going to do here. So let's figure out our feasible bundles. We have a price of X at $4, price of Y is $2. So let's see, we have $20 to spend. That means if we have 0 X's, we can spend all $20 on Y's, and we can get 10 of them. If we have 1 X, we spend $4. That means we have $16 left. That means we're going to be able to buy 8 Y's. Stop! What's the opportunity cost of 1 unit of X? You can figure this out. If you don't know it already, pause the video for a minute. Think about it. The answer will be up in just a second. That's right. 1 unit of X costs us 2 units of Y. That's what we have to give up. So we can actually iterate on that because the prices aren't changing. Remember, we've got a linear budget constraint because we have only one resource in play here. So we're going to have these as our feasible bundles. Now let's go back to the information we had at the beginning of the problem. Don't worry, we'll come back to what these feasible bundles are. Okay, we need to convert our marginal utilities into our total utilities. And remember, don't forget, total utility is the sum of marginal utilities. Okay. So we know if we're consuming 1 unit of X, we're going to have 32 marginal utility. And if that's all we're consuming, we're just going to get 32 utils worth of happiness. What if we consume 2 units of X? Well, we're going to get 32 from up here and then 28 from over here. We're going to add those together. So 32 plus 28 equals 60. The next thing we're going to need to do is figure out what our total utility is if we consume 3 X's. So we're going to get 24 utils from the third X plus 60 that we already had from consuming 2. Whoop, that went a little awry. The best laid plans of mice and men and all that. Alrighty. So we're going to get 60 plus 24. That's that 24 from here. That's 60 from here. Add those together, we'll have 84. Then, for the fourth unit, we're going to have 20 utils from just the fourth one, 84 units from the first 3 we already had, and we're going to get 84 plus 20. That's going to be 104. Last one, we're going to take our 16 that we get from the 5th unit, that's right over here, add that to the 104 that we already had, and end up with 120. Now, pause the video. Fill in the column for total utility from Y. And once you've paused that video and filled that in, come back and we will see how this looks. All right, here we go. We have 24, 44, 60, 72, and 80. If you don't understand where those numbers came from, roll back, watch how we calculated our marginal utilities and total utility for X, and then obviously reach out if you still have any questions. Our next step is just to do a little bit of housekeeping. We want to take this, and we only need the total utility in order to answer this question, because remember, our output from the question is what's the total utility of the bundle, so we can actually nuke marginal utility entirely. That was fast. Okay, now let's put this all together, because we need to take these bundles and figure out what the utility is, not just for each good, but for the whole bundle itself. So let's take a look here. We have feasible bundles on the left-hand side, and on the right-hand side, we have the total utility that we just figured out. So, things to keep in mind, we don't know what the utility is for 10 units of y, or 8 units of y, or 6 units of y. You can probably make a guess based on the fact that there's a pattern of utility decreasing. Marginal utility for the first unit was 24, marginal utility for the second unit was 44, so it went up by 20, then it went up by 16, then it went up by 12, then it went up by 8, so it looks like it's increasing by 4, so we could probably figure out total utility for 6 was 84. Total utility for 8 might even be below that because it's going to start decreasing. But don't worry, we'll be able to answer this question either way. Now, we're just going to go ahead and determine the utility for each bundle. Yeah, slide was there a little out of order, don't worry. So, again, we don't know what the question mark is. We could make an educated guess, but don't worry about it. We get 1 util from X here. We still don't know what our 8 utils are. For 2 units, we're going to get the 60 from our total utility. We still don't know what the question marks are. Probably 84, but it doesn't matter. Now we're getting into ones where we can pick things out directly. We have 84 here, and we have 72. That's coming from 4 units of y over here. We have our 104 that came from 4 units of x. We have 44 that comes from 2 units of y. And then finally, we have the 120 from 5 units of x, and we have the 0 from 0 units of y. All right. So again, we don't know what these guys are. If it becomes important, we can check into them, but probably not very good. Okay. So now we can just add in our total utility. Nothing here, nothing here, nothing here, because we don't know. If we need to figure it out, we can do a sanity check later on. Okay. For the first one, we have 84 plus 72, gives us 156. Then we have 104 plus 44. What's that going to give us? It's going to give us a 148. And then for our last bundle, we have just the 120, because 120 plus 0 is 120. It's the additive identity. All right, but is this bundle optimal? Well, ordinarily, we'd be able to say, well, no, the max is probably below 156 for that 2 bundle, but because we don't have this information here, wow, that mouse is just misbehaving here today. We're going to need to do a little bit of a check. Is this optimal? Yes! Yes, it is. I'll show you how we can do that. Wait, how do we know? Well, we're going to use a rule that we have. All right? We need to go back and take a look at our marginal utilities. Remember, our optimal bundle here is 3x, 4y. So let's go check our marginal utilities there. Let's see. Marginal utility of our third x is 24. Marginal utility of our fourth y is 12. Okay, let's check into this now. Okay, marginal utility of our third x is 24. Checks out. Marginal utility of our fourth y is 12. Cool. The price of our third x was 4. The price of our fourth... Oh, that should say y. Yeah, hang on just a moment. Let me fix that. Price of our fourth y. Why? Because we like you. Is 2. Marginal utility per dollar spent for our third x is 24 over 4, or 6. Marginal utility for our fourth y is 12 over 2. Oh, hey, that's also 6. Why? Y is a crooked letter, right? So we wouldn't be happier consuming more of either good. We're in equilibrium here because a 6 is the same as a 6. Yay! There's no good that we would prefer to consume more of, and no good that we could trade off to be happier. Now, the utility at our optimal bundle is 156. Oh, hey, are we done? Can we possibly be done? Well, let's go back and check the problem. Okay, total utility will be. Okay, well, we know total utility is 84 plus 72, and that's going to be 156. That's our answer.